Hey Jenna, I got the three problems here that you asked about. So the first one, we're just simplifying a radical, in this case a square root, and that's really the key to breaking down a radical, is looking at the index. And of course, since no index is written here, then the index is 2. So we'll keep that in mind as we move along here. So let's just start busting that 128 up. You could bust it up into 64 times 2. Now, I always said back when we were doing this, handle the letters separate from the numbers. So k to the 7th, there's nothing I can do with it written in that fashion because 7 doesn't divide by 2. So I back it off by 1 and I say, will 6 divide by 2? And the answer is yes. So I'm going to think that k to the 7th is k to the 6th and k. And then with the q, it's got an 8, so 8 divides by 2. So we're going to leave it alone, leave it q to the 8th, and then we'll deal with that later in the problem. Okay, now that 64 will go 8 times 8, still got the 2, still got k to the 6th, still got q to the 8th, still got k. Each of those 8s will make a 4 and a 2. Then I still got the 2, still got the k to the 6th, still got the q to the 8th, still got the k. And then each of those 4s will make 2 2's. So I got 2 times 2, then I got that 2, and this 4 will be 2 times 2, and then I got both of these 2's. Then I got k to the 6th, q to the 8th, and k. Okay, now let's see how much we can take out from under the radical. And since it's a square root, a second root, anytime I get 2 of the same factor in the square root, it'll give me a factor outside this square root. So these 2's make a 2, these 2's make a 2, these 2's make a 2. Nothing I can do with that 2. With k to the 6th, 6 divides by 2 and makes k to the 3rd. Done with that. With q to the 8th, 8 divides by 2 and makes q to the 4th. Done with that. And then inside the radical, I'm left with a 2 and a k. And so at the end of the day, I have 2 times 2 times 2 is 8k cubed, q to the 4th, times the square root of 2k. So that's what you were looking at there. Now, let's jump past 14 for a minute and go on to 15. So it had add problems. An add problem with radicals. You can only add radicals if they're like, just like any like terms you can only add if they're like. Right now they're not like, so we can't add them right now. So what we're going to do is we're going to simplify each one of them and then see if we can add them. Well, there's no way to simplify the square root of 2x, so we'll just leave it alone. Let's work on this 4 times the square root of 8x. The 8 will go 4 times 2. And then that 4 will make 2 2's. And then 2 of those square root of 2's will make a 2 on the outside. So it's going to make 8 times the square root of 2x. Okay, and don't forget this square root of 2x out here. Okay, now let's see if we can simplify 8 times the square root of 32x. 32 could go 8 times 4. And that 8 will go 4 and 2, and that 4 will go 2 and 2. And then that 4 will make a couple of 2's. Okay, so now what do we got? These 2's will make a 2. These 2's will make another 2. I got another square root of 2x. Okay, so I'll bring the rest of this stuff down. So we got the square root of 2x plus 8 square root of 2x plus 8 times 2 is 16 times 2 is 32 times the square root of 2x. And now those three radicals are like because they're all square root of 2x's. So we can add the coefficients now. Don't forget that we have a 1 out here. So 1 and 8 is 9 and 32 is 41 times the square root of 2x. Okay, now we'll back up to 14. You had a good start on 14. You want to start by busting that up into the square root of 16 over the square root of 3. And then if you square root the 16, you do get 4. So this is what you put for the answer. The problem with it is, remember, a radical is not considered simplified if you have a radical in the denominator. So we can't leave the square root of 3. So we're going to rationalize the denominator by multiplying by the square root of 3 denominator and numerator, which would have given me 4 times the square root of 3 in the numerator, and then 2 square root of 3's give me a 3 in the denominator. I hope this helps. Let me know if I can help any further.